So next section, machine learning base run. So here we come to the most important point of our project, that is machine learning. So first thing, we set up the data, predictors and target variables. First we shall convert categorical data into numeric format. So we have only one field, which is origin. We have seen that the column origin has values US, Japan, Europe, etc. Now since machine learning understands only numbers, we need to convert them into numeric format. So we use pandas one hot encoding method getDummies. .getDummies is the method to convert them into numeric format under new columns origin Europe, origin US, etc. etc. It will automatically create the name and it will create the columns also for us. We have seen that cylinders are already a part of displacement, so we exclude them. Also, car model names do not help us in machine learning process, so we drop them from our list of input variables. So this is about the feature selection that we are doing for this model, which we had discussed when we discussed the design part. Now let us execute the below instructions to select our features and convert categorical variables into numerical format as I told you. So let's do that part. df cars, df underscore cars equal to pd.getDummies, pd.getDummies, get underscore dummies, round bracket, df underscore cars, column equal to open bracket, caps O, origin. Okay, so we have in here, let's run through whether we have typed it correctly. df cars, these are important instructions, so please pay close attention to this. df underscore cars equal to pd.getDummies, df cars, comma, columns, origin. So origin we're going to convert. So let's try this, shift enter. So it is accepted. Now which columns we are considering? So as we discussed, columns to consider, this is another field we are defining. Columns to consider, to underscore consider equal to, let's type one by one, displacement, go one position forward, comma, single quotes, horse power, next position, single quotes, WEIGST weight, next field, acceleration, next one, single quotes, year. Now this one is going to fall through to the next line, so let us press enter here. Let's go over to the next line, origin Europe. After year comes, maybe we should put the graph backspace, origin Europe, EUROPE, origin underscore Japan, origin underscore US, shift enter. Good. So it is accepted. So columns to consider we are defined to the model, right? Next, let us define our features and labels. So what we know now, X are our features, Y is our label. X is an array, so we give a capital X. That is a convention. X equal to df underscore cars, open bracket, columns to consider. Go next position, dot values. So what does it do? It will drop the index. Pandas will drop the index and it will only give the values. So we are getting an array of all the variables that we have selected and as X. Next, enter, small y, this is our label or the target variable. df underscore cars, open bracket, mpg. So this is our target variable. Dot values. Shift enter. So this has accepted. So we have now what we have done. We have defined our features and labels. X is like I already explained. X is a two-dimensional array representing inputs to the model. Each row represents a car model, and Y is target variable. So each row actually it is called as a sample. So let's keep that in mind. Split the data into train and test. Now here is the instruction to split the data into train and test sets. So let's do that part now. So we have utility given by scikit-learn, train test split, that is a library, and we're going to make use of that. X underscore train, comma, X underscore backspace, X underscore test, comma, small y underscore train, comma, small y underscore test. So we are dividing it into all X into train and test, Y into train and test. So we define all the variables at a time. Now equal to train underscore test underscore split round bracket X comma Y comma test underscore size equal to 0.2 comma random state underscore state equal to 0. Now test size 0.2, it says we want 20% as test data and remaining 80% is trained data. Random state equal to 0 is the seed we give to the model. So these are standard Python seed which you know about. So X train, X test, Y train, Y test. Okay. Train test split. This is the library we're calling. So you split this into, we are telling the pandas to split this into X, Y test size. We are telling this to scikit-learn to split this into train and test. Okay. So shift enter. So it has happened already. X test dot shape. Now let's see what is the outcome. So 0.2 of 394. So let's see how much is that. X underscore test dot shape, shift enter. So it has 79 rows and 8 columns. So that's correct. So here we are using scikit-learn's library model selection that support splitting data into train and test sets. We need to define necessary parameters capital X, capital small y, test data fraction. We have specified 0.2 as I told you, that ensures test data 20% to the input data randomly selected. Now one more point to remember is all these rows, all these values they are randomly selected. So that gives good effect to the machine learning model. Rest 80% is trained data. Now this is all our setup ready for linear regression model. Below is a standard syntax from scikit-learn for defining machine learning model. So below instruction will initialize and train the model. So define and train the model. So that is the next step we do. So let's do that. Regression model. Regression underscore model equal to linear regression. As we remember, this was one of the library we imported. Linear regression shift. Okay. So that initializes that, and next instruction is regression model dot fit. Regression underscore model dot fit. Fit is finding the best fit. X underscore train. So we are keeping the test data untouched, and we are running the sample on the training. So we are training the sample machine learning model to learn this relationship between X and Y variables. Y underscore train. So let's try these two entries. Shift enter. So it has already done it for us. Linear regression, copy x equal to true. This is the response we got. N jobs done. Normalization false. So this normalization will come to in the end. We shall discuss this in what this is. Right now we are not doing any of those. We are just running the plain regression model. Now the fit process, what it has done, it has used the samples from the trained dataset to train the model, which is basically finding the optimum values for various coefficients. Like I said, I'm going to repeat this so that you remember this very well. Okay. So column optimum values for various coefficient a0, a1, an, etc. in the below equation that will minimize the error between y value from the test data, y test, and predicted y value in the hyperplane y pred as we discussed earlier. Y equal to, so this is the equation, y equal to a0 plus a1 x1 plus a2 x2 plus a3 x3 till an xn. A0 is, now this is again, this is important. A0 is a y-intercept, which is the value of y when all x are set to 0. So this is basically like we in the initial example we saw that the distance 25 kilometers that model had traveled, that was a y-intercept. So this is like that. So the output we get out of running this equation will be coefficients a1, a2, etc. and intercept a0. So we also, just to verify, we define 20% of total rows as test. So let's check what we have. So x test dot shape. We know this instruction already. Shift enter. So we have 79 rows and 8 columns. Below instruction will define an intercept that will be populated by a0 value returned by the algorithm during training. So columns to consider, columns underscore to consider dot append, round bracket, intercept, column to consider append. So what we are doing, we had defined the columns to consider right on top when we started with the machine learning process. So there we had defined each of the variables like whatever weight, displacement and all that. Now in the end we are also going to add one more value, which is the intercept. That intercept will be returned by the model and it will be stored in the value intercept. So let us check. Okay, let's run this instruction first. Shift enter. It has accepted it. Let's check what all our columns look like. Columns to consider. Columns to consider. Let's check which all we have. So this is the complete list of columns we have created. Displacement, horsepower, weight, acceleration, year, origin Europe, origin Japan, origin US, intercept. Now we'll check the output of this model. 1 minute. So below we define a table which is again pandas data frame coefdf that has the above column names listed in a column called predictors. The respective coefficients in a separate column called coefficients. A0 will appear as intercept in this label. This part we have already discussed. So this is a long instruction. So I will just do this one quickly here. So we can type we could have typed this out. So here what we are basically doing is we are defining data frame coefdf pd data frame. This is actually a dictionary in definition of pandas. Predictor, I mean Python definition. Predictor is columns to consider and coefficient is np.append regression model coefficient. So regression model, whatever coefficients are there, they will be the best optimum values. They will be appear in this column regression model coefficient and regression model intercept. This is the initial a0 value. So let's run this. Shift enter. So now we will see how this column looks like. So let's add one row here. coefdf. coefdf. Shift enter. Okay. So here we see whatever is the finding of the model is the displacement. It has how much is the impact it basically shows how much is the impact each variable is having on the predictor on the label, on the target variable. Displacement 0.018. So all these fractions, these are say horsepower, weight, they are all going negative. Acceleration is showing so much importance here. So this is actually it's a finding of the machine learning model. Now predict output. Run the test data using our trained model. This is what we'll do now, and generate the predicted Y value. Now what we'll do, we have test data which is 20% of the total data. We had kept it separate. When we split the data, now this test data is something we're going to run now using our machine learned model, and we're going to get the results. So Y underscore pred. This is one more field we're going to define, equal to regression model. This is our model we generated. Dot predict round bracket x underscore test. Shift enter. There is some typing error. Something happened here. Let's copy it from here to save time. Let's see what has gone error. Regression underscore. Maybe some typing error. X test is not defined. Did we not run X test somewhere? Let's check. Maybe there is some typing error somewhere. X test, the shape, X test, train X test. This is all correct.